So to work on regularization methods in Python, I'm going to use this collab of Google in here. You can just search as, let's see, collab, and then you will see that Google has that environment for you. And it just allows you to write and execute your Python code in your browser. And so you can just use it as it's free to use. And you can find an example in here. And so let's start. Let's start for our work. So you can just go File and New Notebook. And now we are connected to the Google servers now. And when you just click code, you will see that you are having code, or you can just click text and just get text in here, okay? And let's see, I can start with a text first. So we will work on regularization methods in Python. Okay. And now I want to import the libraries we will use for today. So we will use NumPy, Matplotlib, and Pandas and Seaborn for the visualization. And Pandas is going to be used for to see the data in a data frame format. And if you are maybe familiar with the Skylearn, we will just get the Boston data sets from Skylearn, and we will use linear regression, reach, lasso, and we will just use the train test split from the Skylearn model selection. And when you just click, you just import in 1 second, and these libraries in here. And first thing I will do that I want to use Boston house price data sets, and just load that data sets in here as X and Y. And here is my X and Y. And I'm going to just use load Boston in here. And let's see, return X and Y true. And then let's give it a name. Boston equals load Boston. And just add this one too. And now what we are going to do is that we want to split our data set as train and test in here, and Y train and Y tests. Okay, so we will train our model in training data sets, and we are going to just check out for the goodness of fitness of our test, or how accurate our predictions in here by using test dataset. Test datasets is just an unseen data by your model first. And so there is a function in Python, which is train test split. We will use this guy and just split our X and Y, and the test size in here, and here is my test size. You can just play with that number. Let's see, I'm going to get 70% of the data as train, and test is 30%. And you can just write a random state in here and to have the same result with me, but it's up to you guys. And here is my train test split function that I'm able to just split my data sets into two, and the measure of the data is in training data sets with 70%. And so we can just print X shape to see the dimensions in here. And let's see how it is working. Okay. So I was able to just have this data set, and it has 106 observations and 13 variables in here, and it's a rectangular data set. And if you want to see, if you want to see some more information about the data set, you can just say Boston.keys, and it's going to give you some more information. Here is what. We have data which contains the information for various houses in these data sets. And target is the prices of the house. And you can think it as dependent variable like in statistics. And so in machine learning methods, generally they call it target. And we also have feature names. And these are the names of the features. And you can see some descriptions about the data sets in here, okay? And I want to get some idea about the data sets. So I want to just convert these data sets into data frame. Let's give it another name, Boston 2 in here. So I'm going to use Panda in here. And let's say data frame. Okay, now we are going to convert our Boston data in here. Okay, and the columns are Boston.feature names. Okay, okay. And let's see the first 5 lines in here. Oh, sorry guys, I just forget something in here. Okay, okay. Now what happened is that, so we just converted our data sets by using Panda library, and we just converted it to data frame, and just by using the features names in here, and you just see the explanatory variables or predictors on your table when you hit the head command, okay? And please notice that in Python, the index starts with 0, different than R. Maybe you remember that the first index in R is 1, but it is different in Python that the first index is 0 in here, okay? And this is going to be your first line. And we have all the variables in here. And by using these variables, we will try to find or estimate the target in here, okay? Target means the price of the houses. If it is just, for example, if CAS or RM or age of the house is has any impact on the price of the house in here. And now after that one, maybe it's a good idea to plot the distribution of the target variable. And let's see what we are going to use in here. And we will just add some options and then plot our data. But here, maybe here. Okay, we run these parts one more time, another call. Here is what I'm going to use. And we are just giving some options first. And here is our this plot. And we will use this target value, which is in Boston 2, and just have our plot in here. Maybe it doesn't know what is happening in here. Maybe we should first define it. So it didn't like what I used in here, and maybe I can just use Boston. I'm sorry, guys. Let me get this part, and here I can use, instead of that one, I can use Boston.targets, which is my target value. And yeah, when I run this part, you see the histogram of your target value, which is the price in here. You see how it is changing. It's kind of red skewed, and we may see one more. You see that we have some peaks in here, and we have one more peak in here too. So this is what we are using some tools to get some idea about your data sets. Also, it may be a good idea to create a correlation matrix that measures the linear relationship between the variables. and add a new code. I want to generate a correlation matrix in here by using my data sets. And here is my data set. Boston dot. I want to just see for correlations in here and just round it to. And also by using this guy, we can just generate an head map in here in CNS. Here is my head map. And my data is going to be my correlation matrix in here, this guy. And by using as true, or maybe true, and true to print the values inside the square by using this annotate option in here, we will just use the correlations inside the square in here. Let's see what I mean. And not true is okay. And I did some typo in here. Correlation matrix round 2. This is my Boston. What happened in there? What happened? Let me see. Okay, okay. Boston.2. Maybe 2. Okay, okay. Yeah. I use the ones. I should use the data frame in here. Okay, please keep in mind that. And so when I convert it to data frame as Boston 2, you see that we are having this correlation matrix map, which is head map, and you can see the correlation between these variables. And for example, these black ones shows a higher correlation, okay? So we are able to see some and the correlation coefficients, which are ranged from -2 to 1. You know that if this value is close to 1, that means there's a strong positive correlation between that two variables in here. And when it's close to -1, the variables have a strong negative correlation matrix. So we even see some correlations about the data set. This is what we have related to our data sets. Now we can just start with our models now. And first model is going to be our linear model. I want to use that one first. And this is going to be very basic linear regression. Let's first define our model. I'm going to use linear regression, which is defined in here. And so first of all, you should train your model. And here is my linear model, and I want to use fit in here. So for train, please remember that we are going to use X train and Y train in here. Okay, so this, and after that, I want to get R square values in here by using linear model. So here is what I want to use linear. Let's give it a name, R2. And I want to use what? I want to use my linear model, which is a linear regression. And in here, I want to get my linear model score. I mean the score in here. Okay, this is going to give you an R square value. And here is my X train and Y train. And also, we want to just get linear test R square. And let's make it similar to the previous one. We have our linear model. And in here, we will just get the score. And as you may guess that this time, instead of train data, we are going to use test data for X and Y. And here are my data in here. And we want to print something, okay? We want to print what? So for linear model, we have our train data, R square, or you can just say R square value, and which is what? So for train, we have this guy. I just need to put it here. Train, linear train this guy. So let's put it here. And also I'm going to print in linear model test data R square value. And then we are going to just add linear test R2 in here. Okie dokie. Let's run this part. When you just check out for your R square, it's not bad. When you try to fit a linear regression, Y versus X values, you will see that the trained data R square is 0.74 and it is 0.71 for test data sets. And let's move to rich regression. Maybe you remember that in regression, we were just adding a penalty term, which is our L2 norm in there. And we were just using that penalty term in rich regression. And let's see what I mean. And we are going to just run regression in here. Okay. So let's generate a model object first. Here is my model object. I have rich, which is defined in here. And you should just give an alpha value. Maybe you remember that alpha was our hyperparameter, and it's an arbitrary number you define before training model, or you can just use some cross-validation methods to find the best alpha in here. But in this Python example, we will just use predefined alpha values and run this rich regression. And so to fit, you can just write rich fit. And let's see, I'm going to fit with my X train and Y train. And after that, we will just get the R square values as before, okay? And I can just get this part, something like this one. I have rich, and after that, I want to get my train R square, similar to the linear regression. So we have our object rich, and I want to get score, which is going to give you R square value. And it's a predefined function in here. And I'm going to use Y train and X train. And then, as before, we are going to use test R square. And again, I have reached dot score, and we have this time X test and Y test. Maybe I just made a typo in here. Here is my X train. Okay, and I also did a typo in here too. Okie dokie, I have my scores now. So now we want to print what? And we want to print our rich and train data R square first. And now what you have is that you have rich train R square. Okay. And then we want to print rich in here as test data R square values. And now this time you have what? You have rich dot test R square. And this is what we are doing for rich regression. It is enough to use this rich. Maybe you can see that rich is just a linear least squares with I2 regularization in here. And also you can see how we are adding that into our objective function in here, okay? And as you may notice that this model solves a regression model where the loss function is a linear least squares function and regularization is given by I2 norm in here. So when you run this part, you will see that now this time your rich train data R square and test data R square is very close to the 1. to the linear regression. And please remember that when you have smaller alphas, and that means you are not giving that much penalty to your betas in here, and it's going to be kind of similar to your linear model there, okay? So let's try another rich regression with different alpha values, okay? Let's add a code in here. And now instead of this guy, maybe you can just copy and paste this part in there. Instead of that guy, we are going to use different alpha value. Let's say I'm going to use 100 now, and we are just doing the same job in here. We are fitting our regression by using X-train and Y-train data sets, and just find the score, which is our R-square. And we also run this part for our test data too, and see how it is changing in here. Now, this time, you have smaller R-squares than before. Please keep in mind that now your alpha is 100, and you are giving lots of penalty to your betas. And that means you almost get rid of all of them. When you have like greater alpha values, it's going to push your model to have your betas zeros in here, okay? It is really high value for alpha in here. And now we see that our train and test R-square is smaller than before. And you may want to add some plot in here to see how our model is changing by using linear model and rich, and also rich 2. And rich 2 is the one with 100. And I want to just put them in the same plot. So we want to add some graphs in here, and here is what we are going to use, okay? And you are just giving the some options before for all of them. For example, for rich coefficient, and for our model in here, for rich in here, your lambda is 0.01. This is going to be your rich, okay? Rich model. And we will adjust star as a marker. And for rich 2, that means your alpha is 100. In here, when you just think about your model, we call it as lambda. And so as marker, we have D, and also we are adding our linear model in here with a difference marker. And when you just run this part, you will see that for our coefficient values, some of them is going to be 0, okay? And when you just check out for your alpha as 100, and you will see that your values are really close to 0 in here, okay? And for rich as the first one, your lambda is really smaller, and your model is really close to one with the linear model, okay? And now, maybe after rich regression, we can just use lasso, and let's add a new code in here. If you want to use lasso, let's give it a name to our object first. And you can just use lasso function in here, okay? And you have to define your alpha again. It's going to be your hyperparameter in your model. This is my alpha. And I want to just fit it by using my X-train and Y-train data sets. And we want to just get our R-square values in here, lasso.score. And so since you write train, we will use X-train and also Y-train in here. And again, I want to get the test value for R-square in here by using my lasso model. And we will just use the score. And now this time with X test and Y tests. Here is what. And I want to print them in here. Let's have this part. I want to print my lasso and R square values, and lasso test R square values. And with a small guy in here, please. Train. Maybe I should just say. Now this time, we can make it smaller. Let's run this part. And now you see that in lasso, the train test R square is 0.74 and test data R square is 0.17 here. And alpha is really small, and you see that maybe it added all of our coefficients in here, and your values are really close to the one with linear model. Now, instead of this alpha, we can just play with that one and just give it another value. And let's see, in this time, I want to give 1 to my alpha in here. I want to try another model. And this is lasso 2 now. And we are going to fit it by using X train and Y train. And now we are going to print R square values for this one. And now we have even smaller R square for this alpha. And let's see, and let's try something else. And now instead of 1, we are going to use 100 in our lasso 3. And now we are just training the model and just testing that one by using test data sets. Oh, it is even much more smaller in here. And it didn't like 100 as in this example, okay? So let's add the plot for our lasso. Here is my code for that one. We are using lasso coefficients and lasso 2 coefficients and lasso 3 and also linear model in here. And for each lasso, we have different lambda values that we tried before. And when you run this part, you will see that when you just check out for linear model, and it's very close to the one with when you have your lambda as small, okay? And for these two guys, it's just really pushing your coefficients to 0, especially for the one with higher 100 value. And with this one, you can get the idea about how your coefficients are changing when you just change your hyperparameter in here. And if you want to see the number of coefficients which are 0 in here, let's say I want to use first my lasso coefficients. Okie dokie. And let's sum lasso dot coef in here. The ones equals to 0. Okay. And you can also see lasso 2 coefficients in here. And now this time I want to use lasso 2, that guy, and the coef equals 0. And as a last step, we will use lasso 3, and let's save it to an object as lasso 3 coefficients, and sum the coefficients in lasso 3, and which are equals to 0. Okay. And I want to print them. Let's write it from here. I want to print these 3 guys in here as my lasso coefficients. And so in here, I made something, so coef equals 0. Let's see what happens in here. Okie dokie. Oh, I did typos in everywhere. Let's just change them. Okie dokie. So when you have your lambda as 0.01, you see that for smaller lambda values, the model pushing your betas to be 0. I mean, not to be 0, and they are, you don't have any ones which are 0 in here. When you have higher lambdas in here, you have higher punishment for your betas, and you have more coefficients which are values are 0 in here. For example, for the one you have 2 coefficients, the values as 0, and for the last one, if you use 100 as your lambda, and you see that 11 of your coefficients are 0 in this example. And if you want to see your betas in here, for example, for the second model, I want to see my betas, and you can just print your feature in here. Let's see, sorry. And these are the ones that you are not using in this second model, okay? You just omit cost and NOx in there, and you are just finalizing your model without these 2 guys in here and use the rest of them. This is all I wanted to explain about regularization methods in Python.